Hey guys, so today we're going to be looking at a few examples of how to combine the product of two bases with exponents as well as the quotients of two bases with the exponents. So if you remember in previous videos, there were two rules that we had. The first one was if I have two bases that are exactly the same multiplied together, I can simplify that by adding the exponents together. So x to the a times x to the b equals x to the a plus b. And same way goes for a quotient. If I have two bases that are being divided, the way I can simplify this is if they're the same base, I can write it all as one base and then subtract the exponents. So this is going to be just something that we're going to keep in mind throughout this whole video. So I like to condense everything on the same side of the fraction as possible. So I will condense the whole numerator and then the whole denominator. So in this case, the numerator has to be condensed. And if I use this rule here, then I am going to make this p to the 8 plus 3 over p to the negative 6, which is just p to the 11 over p to the negative 6. Now, if you remember what a negative exponent is, a negative exponent just wants to be thrown to the other side of the fraction. So if I have a negative exponent in the denominator, I can turn it into a positive exponent if I place it in the numerator. So this becomes p to the 11 times p to the 6 over 1, which is just p to the 17 when I add these exponents together. And so p to the 17 is going to be my final answer. All right, so here we have d to the 0 over d to the 2 times d to the 4th times d to the negative 1. So let's go ahead and let's combine everything on both sides of the fraction. So this is going to leave me with d to the 0 over, and now if we think about what I do here, I'm going to multiply all these together, which means I'm going to add the exponents together. So 2 plus 4 minus 1 is going to be 5. So this leaves me with d to the 5. Now, a quick review. What is anything raised to the 0th power? Any number, no matter what number that is, raised to the 0th power is always equal to 1. So I am going to rewrite d to the 0th power as 1. So it's going to be 1 over d to the 5th. And that is my final answer. And then lastly, we have this big, long example here. And now this is just where we have to make sure we pay attention to good detail and make sure that we combine all like terms. So I'm going to go ahead and I'm going to box the s's in green. So we're going to kind of look at those. So all my s terms here, we notice that s to the 6th times s to the negative 1st. So the reason I can multiply all these s's together is because every number is being multiplied here. Every single variable is being multiplied. If there was an addition symbol in the middle somewhere, I might not be able to do this. But since it's all being multiplied together, I can combine all like terms through multiplication. So what happens when we multiply exponents? Well, that just means that we are going to add the exponents together. In other words, this can be written as s to the negative 6 times s to the negative 1 times s. And then if I focus on the t's, if I focus on the t's, I will notice that I can do the same thing. So I can multiply this by t to the negative 2nd times t to the negative 1 times t to the 9. Alright, keep going. Do the same thing for the u's. My u's are all right here, so I can multiply this by u to the 6th times u to the 0 times u to the negative 4. And then lastly, we'll do this one in black. I have v to the negative 6, v to the negative 1, and v. So I can multiply this by v to the negative 6, v to the negative 1, and v. So let's go ahead and let's simplify these down. So if I take my first law up here again, this is going to simplify down to s to the negative 6th. This is going to simplify down to t to the, let's see, negative 2 minus 1 plus 9. That should give me positive 6. And then this is going to simplify down to 6 plus 0 minus 4 is going to be u to the 2nd, or u2. And then in the black, we have v to the negative 6 times v to the negative 1 times v to the 1. So that is going to leave me with v to the negative 6. So now, when I multiply all of these together, I could write my answer in two ways. Two ways we can write our answer. I can just write s to the negative 6th times t to the 6th times u to the 2nd times v to the negative 6. But if your homework, for example, asks you to provide it in all positive exponents, remember what these negative exponents are asking us to do. We can keep the positive exponents where they are, t to the 6th times u to the 2nd, divided by, and since this is s to the negative 6, I can write it as s to the positive 6 in the denominator, and since this is v to the negative 6, I can write it as v to the positive 6 in the denominator as well. So either one of these answers are basically saying the same thing, but you might have a homework assignment or a test or a quiz that asks you to write it in this form. They're saying the same thing, but you have to make sure you read your directions.